Okay, welcome back to Mr. Hassan's Maths channel. Here we are answering question number 2 from Specimen paper 4 for the 2020 specification, and number 2 is about statistics. The first question in number 2 is about cumulative frequency curve, and it tells us there's 200 students that estimate the volume of a classroom. The cumulative frequency diagram shows their results. So a cumulative frequency curve is made from a grouped frequency table, and basically you are plotting the cumulative frequency, the number of students, for example, who estimated that they got less than 100 and 150 and 200 and 250. They estimated the volume was less than those. You plot those points on the cumulative frequency curve and you draw the curve. So we don't actually have the data, but we have the graph that's drawn from the data. Okay, so what we have to understand is the cumulative frequency curve is made from a grouped frequency table, and you turn it into a cumulative frequency curve. All right, and basically the y-axis tells you the number of entries in the survey, and the x-axis tells you the quantity that they are describing. So here, what's being described is the estimates of the volume of the classroom that students have been asked to make by their teacher, obviously. So 200 of them were asked, and you can see that, for example, none of them estimated that the volume was less than 100. Okay, but for example, you could say that, you can say that 20 of them estimated that the volume was less than around 250. Okay, just over 250 actually. So this is how you can understand this particular cumulative frequency curve. Now it's asking us to find the estimate of the median. Okay, what I'm going to do is, because it's a bit enlarged here, I'm going to actually just zoom out a little bit. Maybe that's a bit too much. I'll zoom out to about 150. That's still too. Make it a bit bigger than that. We'll still be able to see. Okay, I think that's a bit better. We can see a bit more what's going on. We can actually see the whole curve here. That'll make life a bit easier for us. Okay, so now it says use the graph to find an estimate of the median. So the median volume that the students guessed that the classroom is going to have. All right, so now the median is found by going halfway along the cumulative frequency axis, the y-axis. Why is it going along the y-axis? Because the cumulative frequency represents the number of people in the survey, the number of items in the survey. So the number of students was 200, and we want to find an estimate of what did the middle student, the student right in the middle, when all the data is entered in order of size, what did the student right in the middle, okay, what did he or she estimate as the volume of the room. Now, if there's 200 students and they're all ordered in size, then the 100th student is going to be the one which is in the middle, halfway up. Now, be very careful here, because they do sometimes trick you. All right, sometimes the actual curve might go up to, say, 180. It might stop there. Okay, but the axis goes up to 200, and people look at the axis and say halfway. But in this case, it's fine. They both go up to 200. But if, say, the curve went up to 180, you're going to have to take the median from 90, not from 100. So be very careful. Sometimes I've seen that a few times, and it's a bit sneaky, but it does happen. So you should be careful about that. And then you lose lots of marks for the rest of the question, because it's all based on, it being 200. Now, we see where the 100th student hits the curve, and then you see what the estimate is. The estimate looks like it's 400, so that means the median value is 400. The estimate of the median is 400. Okay, so 400. So when it, whoops, left the highlighter on. So when it comes to 400, yeah. When it comes to estimating the median, Okay, as I mentioned, you have to be careful. Now, when it comes to estimating or finding the median, when we have the set of data all given to us, like we know exactly what each set of data is, then we kind of look to see, is there an even number of entries, or are there an odd number of entries, and are there two numbers in the middle, or there one number in the middle? When you have a grouped frequency table, you don't have to worry about that when you're thinking about the median. So this cumulative frequency curve comes from a grouped frequency table. You just take halfway along, okay, because the data is grouped anyway, as we'll see in part B. You'll understand that a bit better. So the data is grouped anyway, so everything's just an estimate. So you just go up to halfway along the cumulative frequency curve. Be careful that the as I said, the actual curve goes up to the top. If it doesn't, it's going to be halfway to as high as the curve reaches its highest point. And then you're halfway along, and then you see where it hits the curve, and you write down that value. So this tells you, this 100 tells you where to look, and that tells you what the actual median is. Okay, it's the estimate of the person right in the middle of all of the students when they're arranged in order of size. Okay, that's the median. Now we have the interquartile range. Now the interquartile range is basically given by what's called the upper quartile, and you take away from that the lower quartile. Now, what does the upper and lower quartile mean? Let's start with the lower quartile. The lower quartile, as you can kind of imagine from the sound of, or the word quartile, it's basically a quarter of the way up the cumulative frequency axis, okay, up to where the curve goes. So a quarter of 200 is 50. So it's like what the person a quarter of the way up estimated. You could think of it like that. Okay, so 50, sorry, that's 40. 50 is over here. That's 50 there. Okay, 40, 60, 2, 4, 6, 8, 10. So 2, 4 and a half between 4 and 6 is 5. So that's 50. Okay, so there we have. Yeah, good. It hits exactly on, hits 350 exactly on the line. So we, whoops, it's exactly 350. Let me just redo that. Exactly 350. So this is the lower quartile. This is the median. Okay, now the lower quartile is also given a symbol Q1, and the median is also given a symbol Q2. You don't really have to worry about that, but if you see that, that's what it means. Q1 is the lower quartile, Q2 is the middle quartile, which means the second quartile, which means the one in the middle, which is the median. And so that's where to find the lower quartile, and that's what the lower quartile is. So the lower quartile is 350, and the upper quartile is found by going, as you can imagine, 3/4 of the way up. So 3/4 of 200 is 150. So we go to 150, which is going to be about there. That's 140, 100, and each of these is 4, it seems. 144, 148, 152, 158. So it's exactly halfway between these two. That's 150. That's not quite halfway. Try and be as accurate as you can. That's a bit better. And it hits it again, I think, exactly on one of these lines. Seems to be. So that's, okay, what is that? That's 400, that's 410, that's 420, 30, 40. Yes, that each of those is 10. So that's 420. So the upper quartile, okay, this is called the upper quartile. Okay, so that is upper quartile, okay, which has got the symbol Q3, as you can imagine. So we got Q3, which is 420, 10, 20, 30, minus 350. 420 minus 350, and that will give us the interquartile range. So you got 420 minus 350, that's going to give you 70. So that's the interquartile range. So basically what the interquartile range is, it's telling us what the middle 50% of the students estimated. The middle 50% of the students estimated. That's how, spread out their estimates were. Okay, so that's what it kind of, it gives us an idea of how spread out the data is. Ignoring the bottom 25% and the top and the highest 25%, you're looking at the middle of the data. So some people on this side might give some ridiculously low answers. Some on that side might give some ridiculously high answers. So if you look at the middle 50%, generally that's a more better indication of how the data is spread out in a sensible way. Okay, now Now we've got to find the 60th percentile. Now, as you can imagine, that probably means 60% up the curve, and it does up the y-axis. So 60%, so 0.6 is 60% times 200, that gives you 120. So we got to go to 120, which is over here. Whoops, that's too high. That's better. Now it hits it just before the line, so we got to be a bit more careful here. So let's now go down, and it's just before the line. In fact, what I'm going to do here is I'm going to actually zoom in to see it a bit clearer. Let's see if we can fit it in from here. I think we can. So yeah, it goes up to here, and as you can see, that's before, it's before this value here. Now this is 400, that's 410, that's 420, so this is about 400, and it's a bit further to the right than it should be. It's supposed to be a bit further to the right, I think. Yeah, about there. So it's like 408, I'd say. 408, 409, I think those would be acceptable. Okay, so the 60 percentile is about 408, I'd say. Okay, I think there will be a range for them to accept your answers. Now, important thing is show your steps by showing these. So like, you know, this is where you found the upper quartile, this is where you found the 60th percentile, this is where you found the median, this is where you found the lower quartile. Okay, so these things, these lines here will help them know that you know what you're doing. It says the number of students who estimate that the volume is greater than 300 meters cubed. So now we got to go to volume. We've got to go to 300 meters cubed, which is over here, and we've got to see where it hits the curve, which is at this point right over there, which is exactly, looks like exactly halfway between these two. So that's 20, that's 40, it must be 30. Okay, so 30 are the number of students who estimated that the volume was less than 300. Less than 300. So the rest of them, which is going all the way up to here, all the way to the top, these are the ones that estimated that the volume was more than 300. So that's 170 students. So the answer here is 170. You don't just read off the y-axis. You see what the question says. If it says more than, greater than that value, then you've got to look at the ones above it. If it says less than, you look at the ones below it. So that's 170 students estimated that the volume is greater than 300 meters cubed. So that's question 2A, all about cumulative frequency curves, done. Now let's go to 2B. I can now just increase the width of the page. That's better. Okay, so now it says the 200 students also estimate that the total area in meters squared of the windows in the classroom. The table shows their results. So they estimate also the area of the windows in the classroom, the area. So they gave the estimates, and the estimates are written here. And this is the kind of thing that the cumulative frequency curve was made from. So they basically took, if I was going to make a cumulative frequency curve from this, just to show you what they actually, how they're made, just so you understand. So you're going to have the area is less than or equal to 60, 32 students. The area is less than or equal to 100, so you're including all of these. That's going to be 96 students. And the area is less than or equal to 150, so you're going to include all of these as well. So you're going to have 80 plus 96, which is going to be 176. And then you're going to have the area is less than or equal to 250, and that's going to be, added these 24, it's going to of course add up to 200. Okay, that's the cumulative frequency table from which the cumulative frequency curve was plotted. Of course, there was a different curve. The one on the other side was about volume. But if you were to make a cumulative frequency curve from this grouped frequency table, you would start like this, and then you would plot on the x-axis 60, on the y-axis 32. So the points 60, 32, 196, 150, 176, and 250 and 200, those would be the values plotted in your curve, and you draw the cumulative frequency curve. That's just a side point to just make you understand how the question on the other page was answered. The part A was how that actual curve came about, just to give you an idea of what the basis of that is. Now, here we're told that 200 students also estimate the area of the windows in the classroom. The table shows the results. So 32 of the students made an estimate of somewhere between 20 and 60. Now we don't know, those 32 students might have all made the same number estimate. Some of them might be closer to 20, some of them might be closer to 60, some of them might have actually said 60. We just don't know. With this information, we have no idea what the individual estimates were for each of these 32 students. But we do know that the estimates were somewhere between 20 and 60, and these 64 students, we don't know exactly what the estimates were, but we know the range was between 60 and 100, and so on and so forth for the other categories. So basically, we cannot find the mean. We cannot calculate the mean, but we can calculate an estimate of the mean. And that's the reason why they say estimate, because we can't actually find what the mean is. So how do you estimate the mean? Well, you estimate the mean by basically estimating what these individual or these groups of students, what they gave, what number that they came up with. So I know 32 students chose somewhere between 20 and 60. I don't know what it was, so I'm going to take what's right in the middle, just to be fair. That's the easiest thing that we can do. So to find what's in the middle of 20 and 60, you add them together and divide by 2, and that's 40. Okay, same thing here. You add them together and divide by 2, that will give you 80. You add these together and divide by 2, that's going to be 125. And you add these together, that's going to be 150 plus 250, which is going to be 400, divided by 2 gives you 200. That's right in the middle of 150 and 250. And for these ones, you can basically just see what the middle number is. But sometimes you might not get some friendly numbers, so you can just add them together and divide by 2. So now I know that 32 students made, they came up with a number that was, we don't know what it was, but we're just saying, let's say it's 40. So 32 students chose 40, we assumed. Okay, so remember, we're finding the mean. The mean is the total sum of all the volume estimates, the total sum, okay, divided by the total entries, the total number of students that made the estimate, which is 200. Okay, so if I want to find the sum of all of these numbers, there's 32 people that we assumed chose 40, then I have to multiply them together. So I'm going to say 32 times 40 will be an estimate of the sum of all of the numbers that these students came up with. Plus, for this group, it's going to be 64 times 80. Plus, for this group, it's going to be 80 times 125. Plus, and for this group, it's going to be 24 multiplied by 200. That's going to give me the total sum of all of the numbers that the students came up with for the area when they guessed the area, basically. And if we divide that by 200, it will give me an estimate of the mean, okay, value that the students came up with. So all I need to do now is put this stuff in my calculator. Let me find the calculator. Here it is. So we're going to have, as we said, let's find some space away from the, okay, so we got 32 multiplied by 40. Let me just make one big fraction. 32 multiplied by, see, I already made a mistake there. Be careful when you're using a calculator. 32 multiplied by 40. Okay, always check in case you press the wrong button. It's so easy to do. Plus 64 times 80 plus 80 times 125 plus 24 times 200 and divided by 200, and that gives us an estimate of the mean number that the students guessed as the area of the windows in the classroom. Okay, so that's an exact answer, so there's no need to do any rounding or anything. It gives you 106 exactly. So there we have the answer to part B. So there's a histogram, and here's the table. So we're going to have to draw this histogram which represents the data in the table. Okay, now a histogram is different from a bar chart. A bar chart, what it does is you just put the frequency on the y-axis, and the height of the bar represents the frequency of the data. Whereas a histogram is the area of the bar that represents the frequency of the data. And histograms are used when the width of each of the categories is not the same. If there's any one that's different than the others, then you have to use a histogram rather than a bar chart, because the area of the bar will look bigger than it should. So to complete a histogram, what we need to do is we need to find what's called the frequency density, which is simply the frequency divided by the width of the bar. So remember, the width of the bar here was 40, and the width of the bar here is also 40, and the width of the bar here is 50, and the width of the bar here is 100. So what we got to do is we got to divide the frequency by the width of the bar. Okay, so what we're going to do is we're going to take 32 and divide it by 40, and that gives us 4/5, which as a decimal is 0.8. That's the frequency density for the first category, 0.8. And then we got to do 64 divided by 40. So we got 64 divided by 40, and that gives us 8/5, which is 1.6. So here we have 1.6. And then we got 80 divided by 50, which is 8/5, which is also 1.6. I can just make sure. 80 divided by 50, okay, which is 1.6 again. So this is 1.6. And then we've got 24 divided by 100, which is 0.24. Okay, so that's the frequency density. And now we got to draw the histogram. So now to draw the histogram, we got for the first bar, it goes from 20 to 60. So it starts from 20. Now this is 0, this is 50. Each of these look like they're 10. So it starts from here and it goes up to 0.8. So this is 0.2, 0.4, 0.6, 0.8. So it goes up to here. So it starts from 20. So it starts from here, yep, to 0.8. Let me make it a bit thicker, the line. Yep, make it a bit thicker. Okay, I think that's better. All right, so it goes up to 0.8, and so that's up to 60. 60 is over here. So the first bar will look something like this. It will go up to 60. Okay, now the second bar starts from 60 and goes up to 100. It goes up to 1.6. So I can just extend this one to 1.6. That's 1, 2, 4, 6, 1.6. Straighten it up. Straighten this up. Okay, and that goes up to 100. So I've got to draw a line on top up to 100. So that's the second bar. Okay, I can draw that, complete that down to there. I'm going to try and be a bit neater than that. That's fine. Then it says from 100 to 150, 1.6 again. So this basically, this line just can continue up to 150, and we're done. And we're done. Okay, so there we have the histogram. Now the last bar here is already drawn for us, but we can check to see if we, in case we have made a mistake or something. And you can see that this is supposed to be 0.24, well this is 0.2, this is 0.3, so it's kind of like it's in the right place. That's 0.2, 4, 6, 8, 10. So it looks like it's okay. So there we have, because if that's 0.2, 0.3 is like here, halfway up there. So yeah, it does look correct to me. So there we have the answer. We've completed the histogram. Now, then it says 2 students are chosen at random from those students that estimated the area of the windows to be more than 100. Okay, so let me just take this table and bring it down here so we can see more clearly. Okay, so 2 students are chosen at random from those students that estimated that the area of the windows to be more than 100 meters squared. So that means these are the students here that estimated that the area was more than 100 meters squared. Find the probability that one of the 2 students estimates the area to be greater than 150 and the other estimates the area to be 150 meters squared or less. Okay, so now what they're basically doing here, this is called conditional probability. They've basically taken out these from the rest of the data. So we're only considering now those people who estimated more than 100. So we're considering this 80 plus 24, we're considering 104 people only. Okay, so our sample is only out of 104 people. Okay, so we got to find the probability that one student estimates the area to be greater than 150 and the other to be less than 150. So you got two possibilities. You got the possibility that the first student estimated it's less than 150 and the second student estimated it's more than 150, or you've got the first student estimated it to be more than 150 and the second student estimated it to be less than 150. And you've got to take all of these categories. So 2 students are chosen at random from these 104 students. So you're going to have the first student. Okay, so let's say we do deal with this. So it's going to be the ones that estimated less than 150 is 80. Okay, so you got 80 over 104 times, and then the ones that estimated it's more than 150, there's 24 students, and those 24 students are still there, but there's one of these students less because we've already chosen him. So it's going to be times 24 over 103. Okay, and then you're going to have the other outcome is that you could have had the first student choosing more than 150, which would be 24 over 104. So I'll just show you what happens. You'll have 24 over 104 times, and the second one is going to be the ones that chose less than 150, which is 80, again over 103. So those are the two possible outcomes, and you can see they'll give you exactly the same answer because this is 80 times 24, this is 24 times 80, and they're both 104 times 103. So we could have just done 2 times this, because we know there's 2 different outcomes of that. We can just do 2 times that, and that would give us the answer, and that's an easy way of doing it. So what we can do is take the calculator, and we can say 2 times, so 2, we can just write the bracket straight away, fraction 80 over 104 times, and then you have a fraction 24 over 103, and we have our answer, which is 480. Does it tell us how to express the answer? No, so we can express it as this fraction, 480 over 1,339. 480 over 1,339. Okay, there's the answer to question B, part 3. Okay, this was about cumulative frequency, and the last one was about probability using a cumulative frequency curve. So I hope you understood that 2 students are chosen only from these particular students. So we're only considering those 104 students. And from those students, we got to find the probability that one of them estimated less than 150 and the other one estimated more than 150. It could be either way around. It doesn't say first of them does. The first one estimates less and the second one estimates more. It could be that, or it could be the first one estimates more and the second one estimates less. So we got to combine both of those probabilities together to get our answer. And there we have finished question number 2. Thank you for watching.